And then CFD analysis is performed again on the new nozzle design, leading to some very interesting results. So in fact, the hub side loss peak is suppressed by about 13% as a result of the controlled stacking condition, close to what we had with compound stacking. But this time there is no increase in the mid-span loss, which is actually almost coincident with the radial stacking result, and this provides confirmation that this unique stacking method is actually able to cut down the overall losses in the nozzle. And let's now compare the exit flow profiles from the different stacking methods, and clearly the controlled stacking results in a very uniform meridional velocity compared to the conventionally stacked designs. And the main advantage from this is that it makes the exit flow angle distribution very uniform, whereas the compound stacking produces a large variation of almost 10 degrees from hub to shroud, which can be highly detrimental to the performance of the downstream rotor. And above all, this controlled stacking is performed in a single design iteration, whereas to achieve the same using conventional compound stacking would certainly require significant trial and error. So in order to understand this improvement from controlled stacking, we can see that the loss scores corresponding to the passage vortices are reduced in depth compared to radial stacking near both hub and shroud. And this is true with compound stacking as well, but the wake is much wider at the mid-span, leading to higher loss figures in this region. And another result of interest is contours of helicity, which clearly shows that both hub and shroud passage vortices are weakened as a result of controlled stacking. However, while compound stacking is able to produce a similar effect near the shroud, it presents a much stronger helicity towards the hub compared to radial stacking. And finally, the difference contours of loss coefficient are also studied to understand which areas of flow result in a loss increase or decrease compared to the radially slacked design. And with controlled stacking, there is a notable reduction in loss inside the passage vortex scores, with only a slight increase towards blade pressure side. However, with compound stacking, the loss reduction at the mid-span, it gets compromised by a significant increase on the pressure side, resulting in an overall higher loss value.